Hi all. In this session we are going to learn about array storage mechanisms and address calculation in an array. First let's understand the concept of array. Array is a composite type which is a collection of homogeneous data items. Homogeneous data items means all the elements in an array should be of same data type. If we declare an integer array, then all the elements should be of type integer. If we are declaring a character array, which is also called a string, then all the elements in that array should be of type character. We cannot intermix both integer and character in a single array. So if we are declaring an array int a of 5, then it will allocate 5 locations in which each memory block will hold an integer value, and it will index each block in the order a of 0, a of 1, a of 2, a of 3 and a of 4. A slice of an array is some substructure of that array. For example, if A is a matrix, then the first row of A is one possible slice of that array. If we are taking the first column, then it can be another slice of that array, and even we can take both rows and columns together to make a slice. So slice is simply the substructure or a subpart of an array. Next, let's understand the concept of row major and column major storage schemes used in array. For multidimensional arrays, the order in which elements are stored in the memory are based on row major order or column major order. In row major order, consecutive locations in memory holds elements that differ by 1 in the final subscript except at the end of rows. For example, A of 24 is followed by A of 25, whereas in column major order, consecutive locations hold elements that differ by 1 in the initial subscript, that is A of 24 is followed by A of 34. So simply in row major order, the elements are stored in such a way that the first row will be filled first, then the second row and then the third row likewise, whereas in column major order, the first column will be filled first, then the second column, then the third column, etc. Let's understand this with an example. Consider a two-dimensional integer array with elements 1, 2, 3, 4, 5, 6, 7, 8, 9. In row major allocation, the first element will be stored in first row, first column. That is, it is stored in A of 0, 0. Then it will store in A of 0, 1. Then it will store in A of 0, 2. Then it will store in the second row, that is A of 1, 0. Then A of 1, 1. Then A of 1, 2. So the row index remains same and it will fill for the entire column values. Whereas in column major allocation, it will works in the other way, that is, first it will fill the column value, then it will fill the row value. If we are saying int a of ij, then I represents the number of rows and j represents the number of columns. So here in column major allocation, it will first store in a of 0, 0, then it will store in a of 1, 0, then it will store in a of 2, 0. So the first column is completed, then it will store in a of 0, 1, then it will store in a of 1, 1, then it will store in a of 2, 1 likewise. So it will fill the elements column by column. So this is how row major allocation schemes and column major allocation schemes works. Now let's consider the array address calculation. So consider an array of having m rows and n columns, and if we want to find the address of a particular element, that is a of ij, where I represents the row index and j represents the column index, then in row major scheme the solution can be like base address plus width of n into I minus 1 plus j minus 1, where width is the size of the data item. That means if we are storing an integer value in the array, then the width will be 4 bytes. If we are storing characters in an array, then the width will be 1 byte. If we are storing a float value, then the width can be 4 bytes. So width represents the size required for storing a single element in that array. In column major scheme, base address plus width of I minus 1 plus m into j minus 1, where m represents the number of rows. Let's understand this with an example. For an array of size 30 by 4, the base address is 200, width is 1. Find the address of a of 15, 3 in row major and column major scheme. So the data supplied here are m is 30, n is 4. Mn represents the number of rows and columns in the array. Base address is directly given as 200, width is directly given as 1. We want to find out A of 15, 3, that is I represents 15, J represents 3. So in row major, base address is 200 plus width is 1 into n means number of columns, that means 4 into 15 minus 1 plus 3 minus 1, which is equal to 200 plus 4 into 14 plus 2, that is 200 plus 58, which is equal to 258. Direct substitution. In column major, we have to use the equation base address plus width into I minus 1 plus number of rows into j minus 1. That means 200 plus 1 into 15 minus 1 plus number of rows is 30 into j minus 1, that is 3 minus 1, which is equal to 200 plus 1 into 14 plus 60, which is equal to 200 plus 74, which is equal to 274. Thank you.